Hello, today we are talking again about factoring, although for today the first term is not going to have a 1 in the front. A here is not going to be 1, which makes things slightly more complicated, although most of our ideas from before still work. One of the new things we're going to do is look for a greatest common factor. If all of the terms have the same factor, we can pull it out to make things easier. We'll see that here in a minute. We can guess and check, which is very similar to how we started last time. But again, the A in the front means we have to pay attention to what's going on in the first two terms. The factor by grouping is also something that we're going to talk about. You can get by without it, but I think it makes your job easier if you can learn it. It's a special trick, I know. We're also going to talk about special products. We did that last time. We're going to look at them again where the front is not 1, just to make sure we understand what's going on there. And again, solving equations, very similar to last time, but we're going to look at some examples where A is not 1. So greatest common factor, what you're looking for here is a factor of all of your terms. So all your terms are multiples of the same number. In this case, all 3 of these are multiples of 3. So we can pull the 3 out front and then divide each term by 3. It makes all the numbers smaller. So 3 divided by 3 is 1. Negative 15 divided by 3 is negative 5. And negative 42 divided by 3 is negative 14. Once we pull the 3 out, the problem becomes easier. In fact, the front now is 1, so we can factor that using last time's rules. We need two numbers that multiply to negative 14 that add to negative 5. That would be negative 7 and positive 2. So there we have it completely factored. Notice the greatest common factor, which we pulled out first, made the problem easier. So we'll do it again. 5x squared minus 35x minus 90, those are all multiples of 5. So when I pull the 5 out, I get x squared, negative 7x, and negative 18. Looking here, I need two numbers that multiply to negative 18 that add to negative 7, which will be negative 9 and positive 2. So greatest common factor. Greatest common factor won't always reduce the front to 1 though, so we need to be prepared to guess and check what's left behind. In this case, 7 is the front, but neither of the other two are multiples of 7, which means there's no greatest common factor to pull out. So we're going to do guess and check. Now the first two aren't just x squared anymore. It's not just x and x. They have to multiply to 7x squared. Since 7 is prime, that's just 7 times 1. So we need a 7x and a 1x, not just x and x. Negative 20, there's 3 or 4 different ways to get negative 20. So that makes a bunch of combinations here. We can you can see them all here. Notice negative 1 times 20, negative 2 times 10, negative 4 times 5. Those all multiply to negative 20. I have all these different combinations. I have to find the pair that's going to have the outers and inners add up to negative 31. So for the first one, notice 7x times 20, that'd be 140x minus 1x. This one is 70 minus 2, which would be 68. Notice it's not 31. Then I have 35 minus 4. That is 31. Now it's positive 31, which since it's the right number, that means this is the correct combination of numbers, but the signs are wrong. So I have to switch the plus and minus signs. So what my actual answer will be is 7x plus 4 times x minus 5. Now just to check that, notice the first two multiply to 7x squared. Outside 2 is negative 35x. Inside is 4x, and the last two make negative 20. Notice the outers and inners are the like terms. They add up to negative 31. So this is the correct answer, 7x plus 4 times x minus 5. Just to make sure we're getting the idea here, let's do this again. 2x squared plus 17x plus 21. To make 2x squared, I'm going to need 2x times 1x. And to make 21, it's going to be 1 and 21, or 3 times 7. I do have to do them backwards because the 2 in the front means it matters which order they're in. So as I'm looking at these, this is 42 and 1 is 43. This is 14 and 3, which is what makes 17. So this is going to be the correct factorization, 2x plus 3 times x plus 7. Here, 9r squared minus 9r minus 10. To get the front there, I can do either 1 times 9 or 3 times 3. And to get the last two, I can do either 1 times 10 or 2 times 5. So that makes a total of 8 combinations, and I have to check them all. Notice the first 4 are 9 times 1 in the front, and the last 4 are 3 times 3, and then the last 2 pieces there are all multiplied to negative 10. So looking here, that's 90 minus 1, that's not right. 45 minus 2 is 43. 18 minus 5 is 13. 9 minus 10, that's negative 1. 30 minus 3, that's 27. 15 minus 6, that's almost right. That makes positive 9. So that means these are the correct numbers, but I have to change the sign, so I need 3r plus 2 and 3r minus 5. That's going to be my answer. 3r plus 2, 3r minus 5. Now, in order to reduce the number of checks I have to make, as I'm guessing, I can actually use a technique called factoring by grouping, and it's similar to what we did at the end of yesterday, where we're looking for 2 numbers. But the 5 in the front is going to change which numbers I'm looking for. So I can't just find 2 numbers that multiply to negative 18. I have to multiply the 5 times negative 18. I need 2 numbers that multiply to negative 90, and they are going to add up to negative 1. So 2 numbers that multiply to negative 90 that add to negative 1. Here's a list of the factors of negative 90. Note the ones that add up to negative 1 are at the bottom here. 9 times negative 10. Now this doesn't give me the final factorization. This actually is these are the coefficients for the middle 2 terms that got added together to make negative x. So I split this now into 2 terms. I reconstruct now it's the first, outer, inner, and last term, where the 9 and the negative 10 represent the outers and inners that were combined when we combine like terms. In order to reconstruct the original factors now, I actually group these. So I group the first 2 terms together, and I group the last 2 terms together. Note if this one is negative, I really should put a plus out here, and the negative sign follows the 10. Now what I do here in order to reconstruct the factors is find the greatest common factor of the first 2 pieces and of the last 2 pieces. So in the front, if you look here, the 5 and the 9 have no common factors, but each term has an x, so I factor an x out front. That leaves behind 5x and 9. Negative 10 and negative 18 have a greatest common factor of negative 2, which I pull out front. That leaves 5x plus 9. If you found the 2 numbers correctly from the step before, then these 2 factors should be the same. Notice they are. 5x plus 9 is the same. So you can pull that way out to the front, and what's left behind is x minus 2. And those are the factors here. 5x plus 9 times x minus 2. Let's do that again. So with new numbers, 7x squared minus 31x minus 20. I'm looking for 2 numbers that multiply to negative 140. That's 7 times negative 20. And they have to add to negative 31. So the factors of negative 140 are 1 and negative 140, 2 and negative 70. Notice those are going to add to negative 68. 4 times negative 35, add to negative 31. So here, this is actually the correct 2 numbers I want, but I split the middle up then into negative 35 and positive 4. So then I group the first 2. Notice the greatest common factor here is going to be 7x. So I pull the 7x out. That leaves x and 5, negative 5. Over here, 4 is going to be the greatest common factor, and that leaves behind x minus 5. Notice these are the same. X minus 5s are the same. I pull that out front. The 7x and the 4 are what's left behind. So x minus 5 times 7x plus 4. Now special products are going to work very similarly to how they did last time. The difference is that the front is going to have a number in front. It still has to be a square. Notice 16x squared is still a perfect square. That's the square of 4x. The 4 squared makes 16 and the x squared makes x squared. The back is a 1, that's 1 squared. Now remember, the middle has to be 2 times this product of the square roots. So 4x times 1, and that makes 2 times 4x times 1 is 8x. So this is a perfect square. Notice I keep the square roots of the front and the back and the sign in the middle. So 4x minus 1 squared. Difference of squares. One of the things you have to watch out for is this greatest common factor. Like I said before, 18 and 8 are not squares, but they are both multiples of 2. Once I pull the 2 out, I get 9x squared minus 4. Those are squares. This is 3 squared, right? Well, 3x squared. And then this is 2 squared, so I need one with plus and one with minus. 3x minus 2, 3x plus 2. So watch out for those special products. You can still use them even if the front isn't 1. When we start solving equations, again, it's going to be very similar to last time. Remember, you need your equation to have 0 on one side. So if you start off and you don't have a 0 over here, you will need to subtract whatever is over there to one side. So we've got to subtract 6 here. That makes a total of negative 24. Now these are all multiples of 6, so I can factor the 6 out. That leaves behind n squared. Negative 18 divided by 6 is negative 3, and negative 24 divided by 6 is negative 4. And this is a relatively small numbers. Note the front in here is 1, so I just need two numbers that multiply to negative 4 that add to negative 3. That's going to be negative 4 and positive 1. Now just like before, we're going to set these equal to 0 individually. N minus 4 equals 0 means n equals 4, and n plus 1 is 0 means n is negative 1. So that's the solutions for this equation. Let's do just one more to finish up here. 3r squared minus 16r minus 7 equals 5. I got to subtract that 5. That gives me negative 12. Notice these are all multiples of... Oh, they're not, sorry. 12 is a multiple of 3, but not 16. So what I need to look for here are two numbers that multiply to negative 36 that are going to add to negative 16. Negative 36 is 3 times 12, or 36 times 1. It's also 2 times 18, which is going to be what we need. 2 times 18, if one of them is negative, we'll add to I need negative 18 and positive 2. That's going to multiply. That's going to add to negative 16, and 18 and 2 multiplies to 36. So now I'm going to factor by grouping. The greatest common factor over here is 3r. So I pull it out front. That leaves behind it just an r and negative 6. Here, the greatest common factor is 2. That leaves r minus 6. Notice the r minus 6's are the same. So I pull that out front. It leaves behind 3r plus 2. Now this has a 3 there, which means the answer is not just negative 2. But again, I just set them equal to 0 individually and solve them out. This one I just add 6. So nice and easy. Here I subtract 2. Notice the 3r I have to divide by 3. So that gives me r equals 6, or r equals negative 2/3. So when a is not 1, I can sometimes get a fraction. It's just one extra step in solving. Alright, well that brings us to the end today. To review what we did, we talked about the greatest common factor. That was new, and that's something you can look for. Make sure you pull it out. It makes the problem a lot simpler. We can still do special products, but remember they look a little different because the a in the front. We talked about guess and check, which you're welcome to use. If factor by grouping messes you up, guess and check should work out, but it involves a lot more checking. Whereas factor by grouping is what I prefer, and you can use that instead. It's not on this list. We also solved some equations. That's the same as last time. So hope you enjoyed this video. Let me know whether you think I'm getting better or worse. I guess I'm a little concerned.